Hi everyone, welcome back. So today we're going to be converting numbers from standard notation into scientific notation. So let's get to it. All right, so you see I have different numbers here that we're going to convert into scientific notation. We're going to start with converting large numbers into scientific notation and then move into converting small numbers, and I've put a bit of a trick at the end. Okay, so let's take this 1,600 right here. Now, if we want to convert into scientific notation, we first have to figure out where we want to put the decimal. And again, if you remember your scientific information format, you know that we're going to have a 1.6 times 10 to something. We've just got to figure out what that something is. So let's convert up to magenta here. Let's see how many places I need to move the decimal place to get the decimal in between the 1 and the 6. That would be 1, 2, 3. So that would just be a 3 right here. So my answer is 1.6 times 10 to the third. Okay, you ready for the second example? Here we go. A little bit bigger number. All right, this time we know we're going to have a 1.25 times 10 to the something. Let's count up and figure out what that exponent should be. So I'm starting here. I'm going to go 1, 2, 3, 4, 5, 6, 7 places. Therefore, I need a 7 right there. Okay, y'all ready for the last large number here? Now we've got a really big one. All right, again, I know I need my decimal place to the right of that 3. So 3.206 times 10 to the, let's count it up, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the 9th. All right, so y'all feeling good about the big numbers? Ready to go on to the little numbers? Okay, so let's try with a moderately small number here in this example. Okay, again, I know my decimal place has to go to the right of that 3, so it's going to be 3.68 times 10. Again, I got to figure out what goes in my blank. Let's count up. 1, 2, 3. So I moved the decimal 3 places, but notice I moved it to the right. That is going to be a negative 3 there. So remember, your smaller numbers are going to have your negative exponents, while your larger numbers are going to have your positive exponents. It's just a general rule of thumb. Okay, let's go on to my next example here. Again, we're getting smaller and smaller here. I know that I got to get my decimal in between this 2 and the 6. So it is 2.60 times 10 to the, count it up, 1, 2, 3, 4, 5, 6. Again, 10 to the negative 6. We've got a small number here. We've moved the decimal place to the right instead of to the left. Okay, last really small number, my last example here. Again, I know my decimal needs to go to the right of that 7. So that's going to be 7.0059 times 10 to the, oh boy, it's going to be a lot of counting here. Okay, so we're starting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whew. That is to the negative 12th. Okay, my last example here, I made it a bit of a trick question. 2.54. And you say, okay, I need to get my decimal to the right of the 2. Oh, my decimal is already to the right of the 2, so I don't need to move it at all. So what do? Well, we know that based on the format of scientific notation, it's got to be times 10 to the something here, right? but we're not moving our decimal point any. We're moving it how many places then? We're moving it 0 places. And if you remember your math, anything to the 0 is 1. So 10 to the 0 is 1. So really what you're saying is 2.54 times 1, which is simply 2.54. Now that was a bit of a trick question, but I just wanted to show you that you can put any number into scientific notation, no matter what. Well, I hope this video helped you practice getting numbers into scientific notation, of course, both larger and smaller numbers. You can see when we got to those really big and those really small numbers, it was quite helpful to convert it into scientific notation. And I also like to put in trick questions that I can think of that you might see on a problem set or possibly a test. Anyway, I hope you found this video helpful, and thanks for watching.